Well, hello everyone. My name is Tomas D'Amelio. As Kirill said, I'm neural data scientist at PurpleGaze, and the title of this talk is PurpleGaze Analyzer, an automatic pipeline for eye tracking data analysis. The idea is tell you about this package that we were been developing for some time. I want to tell you what is PurpleGaze Analyzer about and which are the horizons we are planning for this package. First things first, I will introduce a little bit myself, starting with my background, some things Kirill already told. So I've studied advertising and psychology at the University of Buenos Aires. The academic system in Argentina is quite a mess and it's a bit strange. So I didn't do a bachelor with a major in one field and a minor in the other, but I actually did both bachelors simultaneously. Then I did a master in data mining, also at the University of Buenos Aires. And after that, I went to France to complete the M2 of the master degree in cognitive science at the École Normale Supérieure. Then I started working in machine learning applied to arousal detection, and that led to the PhD project that Kirill introduced, in which I'm currently working on, which is about predictive modeling of arousal with EEG, but also with peripheral measures. And coming back to Argentina, I co-founded two neuroscience hubs, one which is Neurotransmitiendo, which is a community with more than 20,000 followers on Instagram. And then maybe someone of you know about Neurotech, which is a neurotechnology community. It's a worldwide hub of neurotechnology. And we recently launched the Buenos Aires chapter of this Neurotech X Hub. And I have to say that thanks to Kirill, in the last months, I became a total fan of the startup ecosystem. First, I started consuming some YouTube channels that Kirill recommend, and then I started with podcasts and other type of content. So thanks, Kirill, for that. Okay, so getting back to the focus of today's talk, when I started working at PurpleGaze, there were a number of challenges that we were facing, both regarding the MVP launch, so from the product perspective, but also regarding the final user perspective. So from our side, so from the developer side, in principle, we needed a tool that would allow us to pilot data collection. As happens in the development of any MVP, of any minimal viable product, we want the iterations between changes in some core elements of the product to be as short as possible. The main way to do that is, for example, in our case, to assess data quality as we are developing eye tracker systems. So at first, once we got the data, we had to wait until we create and run individual tests to evaluate data quality, but this obviously doesn't scale with the speed we need in the development of a product in a startup. And that related to improving internal processes, but the truth is that being able to pilot data collection in an automatic way is something that is essential for researchers as well. So I will bring an example, something that happened recently in the lab I work in. So a PhD student is doing an experiment with eye tracking to evaluate perception during psilocybin consumption, which is a psychedelic drug. She had no experience working with eye trackers, so her idea was first finish collecting all data and then learn how to analyze data and analyze it. The problem in that, as you can understand, is that she couldn't pilot data collection because she hasn't the tools to do it. So right after she finished assessing subject 15, she realized that something was wrong with the data she was getting, And in fact, data wasn't being saved properly, and for some reason, data files were empty. And this means that she evaluates subjects that are super hard to get and cost a lot of money and time to the lab. And then she noticed that her data was corrupted. So if there is some way to automatically pilot the quality of data, which could be used both for internal processes, but also for the final user, this could be a really useful feature of our product. Regarding also the final user experience, we also face another challenge, which was to improve data analysis user experience. So as we discussed earlier this week in Gil's and Kat's opening talk, problems regarding how to analyze data is in the top 3 of some group of researchers, for example, UX researchers and others. So being able to generate a solution that make that analysis easier could undoubtedly be a good attribute of the product we are launching. So in a usual process in which we use eye trackers for research, we first have data collection, then we have to build this pipeline to analyze the data, and right after doing that, we can observe data we collected. The idea is to address this second step on this process, to simplify it and to avoid the end user to have to create this final pipeline in order to observe data. So instead, she or he can directly explore data, check data without the need of program anything. So this, for example, would allow us to check if everything is okay with the experiment we are running. And in case of my colleague in the lab, this would avoid wasting assessment of 15 subjects in her experiment. So I hope it's clear from the previous points I've mentioned that obviously everything had to be done from an automation-oriented point of view. And what is necessary for this automated analysis? Well, first of all, that it has to be mounted on top of standardization processes. So first we have to standardize things in order to then automate them in a properly and efficient way. So taking all these challenges in considerations and also the internal gaps I've already mentioned, we developed a solution which is PurpleGaze Analyzer. Okay, so what is PurpleGaze Analyzer? Well, it is a Python package that allows first team members, developers, test data quality in order to improve our product in an efficient way. But also, it is a product that is useful for the final user to perform different types of data analysis with the eye tracker. And the ultimate goal, the way in which we provide information for the final users and also for internal use is with this product, which is an automatic report of eye tracker data. Okay, to understand how we reach this final goal, it is important to understand what are the main components of PurpleGaze Analyzer. And this includes different components that allow us to go from standardization of processes with metadata logger and PDF logger that we are going to describe then, to then data analysis components and the components that make possible to complete the report. So when we obtain data with eye trackers, we generally try to relate that data to contextual information about the environment it was collected. So in a typical case of an experiment in eye tracking research, for example, in science or experimental psychology or other fields, we run an experiment and we want to have information about what happens while collecting that data. And that information comes at different levels. For example, we want information about the whole experiment at first, for example, the name of the experiment, the time when the experiment started, in which monitor the experiment was displayed, and these kind of things regarding the experiment by itself. Also regarding the subjects we are assessing, for example, the age of participants, gender, and other things. But then probably we want to have information at a lower level. For example, if we are running an experiment, we want to have information at every trial of this experiment. For example, every screen, every user are watching, looking at, and also the different elements that compose every trial. For example, if there is just one stimulus that is displayed, or if there are two stimuli presented into the screen. So metadata logger allows us to log this information in a structured and standardized way, and it generates as an output a JSON file of metadata. And this is important because this way we could extract this information and then integrate it in an automated way with that analysis. Because as I was saying, the idea is then to relate this metadata, for example, I don't know, the information regarding the stimuli with the eye tracking data, for example, fixations or other features we want to extract from the eye trackers. So, for example, when comparing fixations, when we are looking, or some subject is looking at pictures of nature, compare with pictures of urban landscapes. So that way we have to have information regarding eye tracking data, fixations, but also we have to have this information related to the stimulus participant is looking at, if there are pictures of nature or urban pictures. So it has to be done in a standardized way. So this very same approach can be extended for different types of experimental paradigms. So it doesn't make sense to build it just one metadata logger for every type of experiment. We have to build it in a way that it is possible to scale for different types of paradigms. So we create an organization of the information in the metadata logger in which it could be extended to different types of paradigms independently. For example, if we presented just one experiment, just one stimulus in the screen, or two stimuli, or different experimental conditions that we can find in the different fields in which we want to apply or to use our eye tracker system. So in addition to metadata logging, which is an internal component of our product, we already have the eye tracker data logging, or the BDF logging. This data is stored in BDF files, which is a bitmap distribution format. And this data is obtained from the commands already explained in Rula's talk yesterday, in which this way we can join information regarding the eye tracking system, for example, information regarding screen position, X and Y screen positions, but also pupil size and timestamp in every sample we obtain. So all this data saved in a BDF, then it is converted into a CSV file with a function that we develop, which is with PurpleGaze inside our PurpleGaze Analyzer package. And these CSV files then are used as input for subsequent data analysis. So in these CSV files, we have information not only about eye tracking data, pupil size, screen position, but also metadata information to at some point join information regarding the experimental procedure with eye tracking data. So I just put a screenshot in order to visualize how these CSV are composed. So we have information in the first part of the CSV in which we have eye tracking data, for example, regarding the screen position of the gaze, but also the information regarding the pupil and obviously the timestamp. But then we have information regarding the experimental procedure, for example, which stimulus is presented, the size, the position. So this way, we can complement information both from experimental data with metadata. And as you can see here, for example, in stimuli, stim size, and stim positions, these are lists. So this way, we can put here more than one element at the same time. For example, if the participant is looking at two stimuli, they are going to put in the same list. Okay, so we now have our CSV file integrating with eye tracking data and metadata. So how do we continue? Well, this PurpleGaze Analyzer module has a submodule called Detectors, which is still under development, but allow us to obtain, for example, information regarding fixations. And from these fixations, we can develop then different types of plots and different types of analysis, for example, case plots and also heat maps. So in this way, fixations are, in our internal algorithm, are detected by defining a consecutive number of samples that are within a distance of a number of pixels. So in our case, this consecutive number of samples are 50 samples in which we register fixations, and the maximum distance is 25 pixels. So although this is a default we set based on previous literature, of course, this can be also changed according to the user to the user domain. Okay, so the point is that thanks to these fixations, we can now obtain both gaze plots and heat maps. So the gaze plots, where here we can see in green fixations, these green circles whose size are related to the time spent at the very same point, and then transition between gaze plots related to the saccades appear in red. And of course, we also have the classic heat maps. Okay, so after that, after making this type of analysis, we make the reports, which is also inside the PurpleGaze analysis and the capabilities of the package by itself. So this is in a beta, but this already allows us to accomplish the first step that we had, the first challenges that we faced, which was to build a solution for internal testing, for example, for product iteration and data quality testing. But on the other hand, this is also a good tool that was built on top of standardization processes that would make in future work to make all the processes regarding the final version for users be more efficient. So what are the future steps of PurpleGaze Analyzer? Mainly, in the first instance, the idea is to expand the type of analysis we can make with PurpleGaze Analyzer. For example, expand it with prepiometry measures, which is an integration, for example, with things that already Lucy showed us on Tuesday, but also, for example, blink detection, which is something that has not yet incorporated in this beta of PurpleGaze Analyzer. And as Lucy was telling us a couple of days ago, there would be now an integration work between PurpleGaze Analyzer and the DASH reports she was showing us in order to complete the point of providing the analysis solutions at least an exploratory level and in an interactive way for the end user. And for that, Dash sounds like a very, very interesting tool, as Lucy showed us. And this automatic generation of reports through Python with physiological variables is something that we already seen. For example, there is a Python library which is MNE, which was built not for eye tracking data, but for EEG and MEG, magnetoencephalography, data analysis. And this is something that is really highly valuable for the end user. So the idea is at some point use these insights regarding the reports, for example, are built on ME and built from PurpleGaze Analyzer reports that are similar at some point to ME, obviously adapted to the eye tracking functions. Okay, so right now, the idea also would be, for example, to add more statistics at the subject level, for example, in order to summarize information of particular subjects, for example, to be able to see contrast. For example, if we want to compare, as I was saying a couple of minutes ago, image regarding urban and natural landscapes. So if we want to compare that in an individual subject, the idea would be to have that capabilities internal of our package, which is PurpleGaze Analyzer. But also we can think about the possibility of making analysis by group. For example, comparing, as we are looking right now, comparing groups of ASD, autism spectrum disorder, with typical development. So the idea would be to scale in order to arrive then also to this kind of group analysis, and that this kind of group analysis could be made in an automatic way, as I've been showing before. The idea of this group analysis would be, for example, at a rudimentary level, have some kind of statistical analysis, descriptive statistics. For example, when running a pilot test, but also, for example, in a phase 2 of this development, to include some kind of inferential statistics. For example, if we have two groups, and if we have a typical development and autism spectrum development group, compare these two groups, selecting some variable, some eye tracking feature, and for example, complete a t-test in which we can compare two groups. Or for example, if we have three groups, I don't know, typical development, autism spectrum disorder, and ADHD, implement a one-way ANOVA, in which we can compare the three groups and assess if there are differences in some of these. Or even in a last point, implement some machine learning model to allow to separate between two conditions based on some features we choose. So this way, the idea with PurpleGaze Analyzer, and the idea that I wanted to tell you today, is to make at some point that the final user, which even in case it is not very familiar with analysis, could have an end-to-end analysis solution with our eye tracking system. So thank you very much.